Hello everyone, I'm Shomi Das from IIT Kharagpur presenting our paper TM-COS Thresholded Multi-Criteria Online Subset Selection for Data Efficient Autonomous Driving. This is a joint work between IIT Kharagpur and Hewlett-Packard Labs. Large fleets of autonomous vehicles are released every day for collecting data using different sensors. This leads to a collection of huge amount of data. Our aim is to study the problem of data-efficient autonomous driving systems. Straight road frames are mostly redundant, while the images during the turn are necessary for the driving models to decide its move at junctures. We show an example of episode completion here trained using uniformly skipped subset. It fails to complete more than half of the episodes. Hence, we propose a multi-criteria online subset selection framework for selecting informative frames. We present a high-level picture of the selection framework. The card provides video feeds. There are two blocks. One is the multi-criteria OSS framework. The other is the stored data where some existing data is present in the reduced data block and the required model parameters are also available. However, the training using the data is happening on the cloud, after which the parameters are being shifted back to the stored area. The existing data, the incoming frames and the model parameters go as inputs to the selection framework that returns some selected frames which gets added to the existing data. This entire selection operation can happen on an edge device. The high-level idea of our work is, given a compression ratio, we want to find the frames which have the least dissimilarity and highest task-specific loss. The least dissimilarity ensures diversity, while the high task-specific loss ensures that frames failing to predict some situations get chosen so that post-training on such selected frames, the model improves on those tasks. Thus, we design a framework that takes care of both these pairwise and pointwise criteria. We name our method TM-COS, a thresholded multi-criteria OSS. We use facility location objective function involving multiple criteria. Here G is the objective function that has two optimization variables ZO and Zn, which are denoting whether an incoming element is represented by an instance from the existing set O or incoming set N. There are three constraints, the first one ensuring each incoming instance has one representative only, the second being the domain of the optimization variables, and the third being the compression ratio. The objective function G gets expanded where we see that the first part checks on the pairwise metric, the second looks at the pointwise metric. Both these metrics are weighed by a factor of rho. The last part is defining the variable associated with the pointwise metric, which defines the representative power of each element thresholded by epsilon. This thresholded S variable is a key innovation in this paper. Coming to the justification for thresholding, this is the theorem that mentions the conditions for an instance from an incoming set to become a representative. They state that an incoming instance J can only be a representative for an incoming element I if it has the least function value Qij compared to any other element. This Qij is a function used in our earlier work where it is defined as a weighted function of pairwise and pointwise metric. This is its objective function where we can see that there is no direct relation with the compression ratio. Also, when we put all the weight on the pointwise metric, that is rho is 0, we can see that the dependency on I does not stay anymore and hence only one element, either from existing or incoming set, gets chosen as the representative for all incoming elements. This motivated us to delve deeper, and looking at hindsight, one can now relate the use of the thresholded S variable in our TM-COS formulation. Going ahead with this method, we evaluated on driving simulator Carla and some real-world benchmark datasets. We use conditional affordance learning or CAL model as the driving model. Here we discuss episode completion results on the driving model only. CAL uses affordances like relative angle that is essential for determining steer values important during turns. Hence, we introduce two variants of TM-COS, TM-COS TL that is using total loss of all the affordances and TM-COS BL that is using bucket-specific relative angle loss aided with other combined losses. We show the completed episode numbers for 100:20 and 100:7 compression ratio on the one-turn task. We can see that TM-COS TL and BL perform better than the others, with TM-COS BL being the clear winner. Here we show an anecdotal example for an episode where in the left plot of relative angle versus the cumulative distance, we can see that the car was moving straight till some point of 0.068 on the x-axis, after which it has encountered a left turn. We can see that the red line for MCOS starts deviating from a little before, leading to cumulative errors, thus failing to complete the episode. We also see the absolute error on the right side plot where we can notice the difference is higher for the red line from the time it started deviating. We also demonstrate this episode on the simulator where we can observe that the MCOS driven car on the right hand side will shift towards the sidewalk while turning, leading to a failed episode, while TM-COS BL will complete it successfully. In conclusion, we proposed a novel thresholded multi-criteria OSS TM-COS that is effective on driving simulator. We also propose a submodular variant named as sub-MCOS. We show comparable accuracies of our proposed method to that of the whole set even after dropping 80% frames. Thank you for listening.